Hey, yo, 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 yo. All right. We're going to talk about modeling with quadratic functions and what that means and what that's going to look like. So basically, we're going to apply the quadratic function and solve some problems with it. But one thing we are learning is what's called the vertical motion model, and this is the formula for the vertical motion model. Now, this h right here, we can draw some arrows to this. This one right here represents height in feet. My pen's not working. That's not good. So this one represents height. I'll just use the mouse for right now. Okay, this v is the initial velocity of whatever the object is. And then this h right here represents the initial height of the object. All right, so you'll just need that information. We'll get into and talk about what all of this means though in a little bit once we start doing some problems with it, but our first problems are not going to include it. And so, oh, now it's working. Okay, our first problems will not include those, so we'll just get into it in a little bit. So, company offers rectangular pool sizes with dimensions as shown. So here this pool we have is 2x wide, x long, and then the deck around it is 4 feet. Okay. Each pool includes the deck around it. If Carolina wants a 15-foot wide pool with the deck, how many square feet will she need to have available in her yard? So first what we're going to do is we need to write a quadratic function to represent the area of the pool and the deck. So we're going to let x be the width of the pool. Okay, because here's our width. So then now what I'm going to do is I need to figure out if we're including the deck, I need to include these two sides with the deck. So one side is going to be 2x plus, well, this is 4 and this is 4, so that'd be plus 8. So that is the length of the pool. The other side of the pool is, and this is the width, is x, but then we also have to include the deck and the deck, which is another 4 feet and another 4 feet. So that would be x plus 8. So the x includes the pool, the 8 feet is the 4 feet of deck on each side. And I know if I multiply these two, that'll give me the square, that'll give me the area of the entire pool and deck. So now this doesn't look like a quadratic function, not just yet, okay? But what I can do is from here, what I can do is I can change it to a quadratic function by multiplying. So 2x plus x, 2x times x is 2x squared. And then I have 2x times 8, and that's going to give me 16. Oh. There we go. 16x. Then I have 8 times x, which is 8x, and 8 times x. 8 times 8, which is 64. So when I multiplied all of this, the quadratic function to represent the area of this pool and deck combined is, oh, there we go, 2x squared plus 24x plus 64. So what I did is I just found the length, I found the width, including the deck, combined those, multiplied them, because length times width, and then this is what I got. So now what I want to do is I want to figure out, all right, well, if I want to find the area of the pool and the deck, I'm going to substitute in a 15-foot wide pool. Well, we said x represents the width, so I'm going to substitute in 15 here. So I'm trying to find f of 15, and so that means I'm going to substitute in 15 for x. Well, that'd be 2 times 15 squared plus 24 times 15 plus 64. Now is where I got to do a little bit of math. I got to square my 15 first. That's 200 and, whoops. Sorry, I'm having the pen issues. 25. I need to do 24 times 15. I don't know that off the top of my head. So let's just do it. 24 times 15 360 plus 64. So now when I multiply these, I get 450 plus 360 plus 64. Finally, that's going to give me 874. So if she wants a 15-foot wide pool, she needs to have 874 square feet available. Okay? Now, let's use the same pool. Let's suppose the length of the pool in example 1 is 3 times the width. How does the function that represents the combined area of the pool and deck change? So if I go back to this one over here, on this one, the width of the pool was x, so this length was 2 times the width because that's just 2 times x. That's double the width. So if I wanted to suppose the length of the pool in example 1 is 3 times the width, the only thing that's going to change is this 2 right here, because this is already showing that this is double the width, would become a 3. So now it's just going to become 3x, which is going to make that 3x, which is now going to make that 3x squared, and then when I multiply 3 times 8, that's going to make this part 24. So that's going to make this into a 32x. So the function just changed a little bit because I had to change this to 3 times because this is triple, but before it was doubled. And that's it. Okay. And it's just asking me how does a function change. And then when I wanted to, if I wanted a 15, I can then plug it in, but that's it. All right. Now, this is the one where we're going to go into our vertical motion model. Okay, so vertical motion model is something where it shows the model of like a diver jumping up and then down. So first, a diver jumps off a high platform at an initial velocity of 16 feet squared. And we can see right here his initial height, he is starting up 30 feet above the water. That's his initial starting point, 30 feet above the water. And his initial velocity is 16 feet squared. So we can use the vertical motion model to write a quadratic function to represent his height after t seconds. So we know in the vertical motion model that's h of t, of time, is equal to, and I know that's going to be, we always know the beginning is 16. And that would be t squared. Sorry, I used x out of habit. Because t represents time in seconds. Now, this is where, if we remember when I pointed out in the original v here, this is our initial velocity. Well, the initial velocity is 16 feet per second. So that's plus 16t. 16 feet per second. So there's my initial velocity. And then the h represents the initial height. Well, the initial height was 30 feet. And that's it. So there's my formula. So this part's always the same. And then you're just plugging in the values for the middle term, the b term, and then the c term. Now, how many, should be feet. How many feet above the platform will the diver be at the highest point of his dive? Well, the highest point is always the vertex. So now I need to use this to find the vertex. So I know that for the vertex, we'll use x and y just so we don't get confused here, is x equals negative b over 2a. And again, remember that's negative b over 2a, put the negative on the b, it shouldn't have been. Well, so let's see here, that's 16. Again, the pen's just being frustrating, so let's just write it out. B is 16, 2 times a, which is 16. So that's 16 over 32, which is 1/2, and it's negative, and that makes sense because we have an upside down parabola. So at 1.5 seconds, okay, so we know at 1.5 seconds is where we're going to have our velocity. Okay, that means where we're going to have our x value. I paused there because I figured out I made a silly mistake because So I'm like, how did I get a negative time? It doesn't make any sense because it should have been negative 16t in my initial function. I messed that one up. So my a was negative 16, and that's just going back to our formula. I just forgot the negative sign. I was stumped. I'm like, how did I get negative 1/2? That doesn't make sense to be negative 1/2 in time. So once I have that double negative, because that's negative 32, it's going to be negative 1/2, but now we have the negative in front. The double negative makes it positive. Sorry about that. If I confused you, I apologize. But I just forgot the initial negative sign in my initial formula. That's part of it. Okay, so anyways, so at 1/2 second is when they're at their highest point. So now I got to figure out what height is that after 1/2 second, after a half second. So I need to actually plug in that 1/2 into the initial function. And again, that's negative. Don't forget Gradius. So after 1/2 second, how high is this diver? Plus 30 feet. And this is where I just got to start solving. 1/2 times 1/2 is 1/4. 1/4 times negative 16 is negative 4 plus 8 plus 30. And that's half of 16 is 8. Oh, I get 34 feet. So the vertex is at 34 feet. That is now my answer though. So if this is at 34 feet, he's already starting at 30. The question is, how many feet above the platform will the diver be at the highest point of his dive? Well, his highest point, he's at a total of 34 feet, which would be 4 feet above the platform. So my answer is 4 feet. Okay. Now, we want to find the diver's maximum height above the water if he dives from a 20-foot platform, and the initial velocity is 8 feet. I want you guys to set up this quadratic function on your own, and then find the maximum height above the water if he dives. So set it up on your own, and then find the vertex and answer the question. Pause it, go. Okay, so I know my initial value is going to be negative 16t squared. Now we're going to start with our initial velocity, which is only 8 feet per second, so that's 8t, and then now we're only starting 20 feet high. So that's like the y-intercept, which is 20 feet. Now I need to solve for the x value first, so that's negative b, which is 8 over 2 times negative 16. 8 over negative 32 is negative 1/4, plus that negative makes it positive 1/4. So I know it's only going to be 1/4 of a second until that diver, when it reaches its max height. Now I got to plug in 1/4 here, so that's going to give me, so I can find out the maximum height here. So that's going to be at negative 16 times 1/4 squared plus 8 times 1/4 plus 20. 1/4 squared is 1/16 times negative 16. That makes it nice and easy because it's just negative 1. 1/4 of 8 is 2. And then we add the 20. That's 21. So 21 feet at the highest point above the water, so I can actually leave it at 21 feet. And that's it. I am all done. Okay, that's all. So things to remember, I'm not even going to put anything in there. And then independent practice, try it out. There you go. And if you have any questions, let me know. Thanks for watching, guys. Gradius out.